Thank you very much for being here today, especially given that it's a warm and sunny Saturday in London, which is like really rare. So my talk today would be about building a classifier to distinguish between train and car journeys using telematics data. So about myself, so I studied applied mathematics and statistics at university, which I believe makes me more of a type A data scientist, which is what they call these days. My first experience was actually in finance, working as an analyst in the asset management industry. But I ended up escaping the city at the end of 2013, as I was very curious to see what was happening in the tech sector in London. I joined Halo at the beginning of 2014, where I had the chance to meet Stephen and Linda, and later Jan, who is one of the organizers. And that's the reason why I'm here today, because I felt in the infamous, that will be great for talk, trap. I joined MyDrive Solutions at the beginning of this year, in February, and I've been focusing on telematics data. So I would like to start by giving a short introduction on MyDrive Solutions, so you can understand better the type of data that the company collects and the products that are created using this data. So MyDrive is like centered around data science and software engineering, and I'm quite lucky to be working with like a relatively big team, given the size of the company, which is at the moment 36 people. So working with me on data science, we have Blanca, Dave, and Zulfi. We're also very lucky to have 2 big data engineers, which are like very coveted these times, Maris and Bogdan, and also Masha, who spent a lot of time working on this project before me and who is currently in Croatia finishing her master thesis. That's why she cannot be here with me today. So MyDrive Solutions is a London-based company founded in 2010. It got acquired last summer by Generali, which is one of the leading insurance group in the world. So Generali is currently serving more than like 65 million customers in 60 countries. So MyDrive is now deploying its technology in Generali's different markets. And basically the core product of MyDrive at the moment is driver profiling, but the company is also looking to apply its competences to e-health and smart home solutions. So MyDrive provides end-to-end telematic solutions, which means that we use a variety of devices to capture driver's data. So it could just be a mobile application. It could also be an onboard device or a professionally installed device in the car. So we ensure that the data collection is as accurate as possible. And we also contextualize the data against the road topography, because it's not the same driving, of course, in an urban area than on a highway in the middle of the countryside. So this is just like a small example of the type of data we'll be capturing. So we will be capturing some driving events, such as like speeds or braking at junctions, accelerating from junctions, and also the road context around this event. Oops. So this is like a brief overview of the pipeline. So we start by capturing second by second GPS data from drivers. The data is then sent to S3, and we have an ETL, a geocoding, and a map matching workers that clean and ensure that the data is accurately contextualized. We then have another worker that identifies the events we are interested in, such as speed, braking, and acceleration. The data is then aggregated, so like the usual period we're using to calculate driver scores is a 90-day period. And the driver score is then sent to the relevant party, insurance groups usually. So in terms of the output on the end customer side, so drivers get two key outputs. Like the first one is that they can look back at the trip history, and for each trip they can see like how they perform, like what mistakes they made. And MyDrive work quite closely with ROSPA, which is a society that is like focusing on preventing accidents to make sure that we provide the most efficient safety trips to ensure that we prevent as many accidents as possible on the roads. And the second output is the driver score. So drivers can see how they have performed overall historically, and sorry, and they can see if they're like making some progresses, or if at some time they started like paying a bit less attention. We are breaking down this score in like 4 sub-scores, so driver can really learn from that process. So I will now introduce the data challenge, because you might wonder why do we need a classifier to distinguish between train and car journeys. As I mentioned, in some regions we are using a mobile phone application to capture the data. And this is great because it has an auto start feature, which means that when the phone identifies that you are in movement at a speed that is higher than walking, then the data gets recorded automatically. That means that MyDrive gets more data, and it also helps us prevent fraud, because some drivers, if they had the choice to record everything manually, might want to hide some trips where, you know, like they're in a rush and they know they're going to be like speeding across town. But also, like, the issue with these auto start features is that sometimes some journeys that should not be recorded get recorded. And because the product is all around personalization, we want to make sure that we only take into account trips when you are the driver. I'm not that guy. This is because actually you get some angry calls from like clients when you like tell them that we're like speeding at a crazy pace across town when they were actually on a train to work. In terms of like the data and the tools that I've used to tackle this challenge, the first data set is MyDrive's internal trip data. So we are, as data scientists, we are quite lucky to have access to highly precise second-by-second data. And so for each point of a trip, we get at a minimum the trip ID, the latitude, the longitude, the timestamp, the speed recorded by the device, and some measures that will help us assess the quality of the data, such as the number of satellites. And you can see that for this car journey, the points are like nicely snapped along the roads, and you can see where like the driver was speeding a little bit or like braking before a junction. The second data set is actually coming from here, which is our map providers. And we get different like shape files with some information about the regions in which we operate. So we get the road links, but we also get the rails and interestingly for this project, the train stations and the commuter rail stations. So I transform like those shape files into a table with the station name, the type of stations, the latitude and the longitude, and merge it with the trip data. So in terms of like the tools, I use QGIS. That's what you saw on the previous slide, to easily explore the different shape files provided by here. Because of my background, I must admit that I'm mostly a R user, so I use R with like RStudio to do some exploratory data analysis and some visualizations, and also to build an initial model. So I use ggplot2 and leaflet on the visualization sides, and Caret to train and test the model. I also took advantage of a library called like Geosphere that allows you to calculate variables such as like the perimeter of a trip, or like the shortest distance between a start point and the end point of a trip. And at the end of the talk, I will show briefly how I implemented these models in MLlib. And I've also used Spark, SQL, to extract the features I was interested in. Because as I'm working with like points data, which are like stored in S3, Spark is really making my life easier. So let's start looking at the data and the different like variables that are interesting for this type of project. So as I mentioned, I use Spark and the Zeppelin notebook to extract and compute the different features. We use AWS, and the Zeppelin notebook is nicely integrated, so it's really easy for engineers when they start a cluster to also launch a Zeppelin notebook. So as you can see, I can load some files that are like stored in S3, in that case as like Parquet files, and transfer them into a data frame. And you can use then Spark, just like SQL queries, to create some new data frames from those original data frames. So if you come from an analyst background, this is a bit easier than jumping straight into Scala and RDD. Also, like a nice feature of the Zeppelin notebooks is that using SQL queries, you can create some simple visualizations to help you understand the data along the way. So when you think about what differentiates train journeys from car journeys, the first feature that might come to mind is like train station, because it's quite obvious. Like if you're like on a train, you like cross a number of stations, which is not necessarily the case for cars. And when you plot the distributions for the data set I was looking at, you can see that indeed the median number of stations for train journeys is 5 and 0 for car journeys. So at the very beginning when I started this project, I thought it would be easy. I would just look at train stations and that will like get me my train trips. However, when I started like looking at the false positive, I discovered that even outside the cities, rails and roads can run really close to each other and sometimes even like overlap. So you can see like the red dots are like the 1 second data of a car trips along a road, and you see it's like crossing the rails. And also the station centers that we get are like sometimes on the roadside rather than being on the rail side, which means that the cars could be actually like closer to the station centers than the trains. So we need to add more information. Another interesting variable is the percentage of points snapped to roads. When MyDrive processes the data, we make sure that the GPS points are like correctly contextualized. So we match them to the closest road links. And so if you have like a train journey and you look at, a car journey and you look at the process data, you'll see that they're like nicely aligned along the roads. However, if you look at a train journey, you will have some big gaps, and you only get snap points when the rails are like close to a road. So if you take like the ratio of the number of points snapped to roads over the number of the road data points, it's also like really simple. You can see that for train, the median is like 50%, and it's much higher for cars. So sometimes we have bad data for like car trips because of the phone or the coverage in an area. Another interesting variable is path efficiency. So to give you an intuition of what path efficiency is, when you plot a car journey next to a train journey, you can see that the car journey is much more, wiggles much more, and you can even like spot visually like things like roundabouts or like short turns in cities. For train, like those journeys are like much more direct. It's almost like no wiggling going on. So in order to capture that, so I use the Geosphere library in R, and I took the ratio of the shortest distance between the start point and the end point of the trip over the total perimeter for the trip, including like all the wiggles. And again, when you plot the distribution, you can see that the median path efficiency for train is 83% and 66% for cars. So speed is also an interesting variable. So when you plot like the speed for a train trip, it's nice because you can see then when the train is like in an urban area, it goes quite like slowly, and the stations are quite close to each other. However, when it's is out in a more kind of suburban zone, the speed increases between stations and then decreases again as the train gets closer to a station. And if you, actually it's quite nice, when you plot the speed versus time, you can see those like big variation for train journeys, while like cars, the variation will be like much smaller and close to each other because of all the brakings that you have to do because of like red lights, cats crossing the streets, or whatever can happen in a car journey. So the median standard deviation for train trip is higher than for car trip. So we considered also like some other variables coming from like the events we are collecting, such as the braking average, the braking standard deviation, saving for acceleration, the distance of the points to like the closest like road links. But after some initial analysis, actually the three variables that were the most like significant and were helping the classifier the most were the percentage of points snapped to rows, the train station per trips, and path efficiency. And sorry, it's a bit small, but as you can see, those variables are very little like correlation between each other. Cool, so let's now start looking at the models. So the first approach I use is actually a simple like logistic regression, using like those three variables and using cross-validation as part, then for cross-validation as part of the carrot package. And so.
Sorry, could you reiterate the purpose of the model? What is the model trying to answer?
Oh, sorry, yes. So the model is classifying train journeys versus like car journeys. So we want to detect for each driver its train journey, so we can like remove them from like the scoring pipeline to ensure that the final score only like reflects is driving behavior.
So did you manually tag up the data to make this into a supervised learning model?
Yes, that was painful.
Okay.
We're actually like looking at, because we have in production like obviously like an easy approach as we're already like snapping the points to the rows would be like to snap them again to the rails, but that's quite intensive. But what we are looking at like going forward to kind of like increase the training set as we move to like some different countries and ensure that it generalizes well. We want to build like a simple like snapper to the rails, so like the labeling is automatized and not manual.
So what made you decide making this into a supervised versus unsupervised problem?
Yeah, well, because I mean, as I mentioned, like a colleague of mine had like started working on distinguishing between train and car journeys. So I had like a data set to start with, and basically I felt that as I was getting some promising like result, I was just going to continue with this approach. And as my initial like model had already like some good performance, I could more easily then get more and more train journeys. So yes, just so the accuracy for the initial model was 86%, under under IUC 0.96. So the second approach. Oh, I'm sorry, and I mentioned like something that's more on the practical side of like doing data science in the private sector. an advantage of like this model when you're like working with like a lot of like different like external clients, because we not only work with Generali, but we also work with other insurance providers in countries in which Generali doesn't operate. Is that like logistic regression is a bit like easier to communicate and to have approval from the client than if you come up, with like a black box where people can be a bit more dubitative. And also at the moment, this type of model is much easier to get implemented in our production pipeline because we are dependent of software engineers to get the work of the data science team in production. However, like I started like to explore like some alternative type of models, and like random forest gave some even better like results. So that's definitely a model I will keep looking at in the futures as we start getting data from more and more countries. And so, as a disclaimer, I don't have a lot of experience with PySpark and MLlib, but as a team we feel that this is the type of approach we should adopt going forward. And our data engineers are working to get a new data pipeline in production so we can independently retrain and implement models. And actually, it was relatively easy to build the model using MLlib and PySpark. I had to do just like a few tweaking with the model parameters to get the same results as I got in R. So I just had to parse the training and the testing sets to have label points RDD, and then apply the logistic regression.
The fire alarm system is operating in City Gate House. Do not use the links between these buildings until further notice.
Yeah, I don't want to be responsible for the death of everyone in this room.
Is operating in City Gate
House. So okay, I'm almost at the end of my talk anyway, so you can run away whenever you want.
Fire insurance as well, yeah.
Yeah, actually that's why I've been like a good partnership for next year for like fire hazards. So yeah, so so like small like tweaks, and I saw a lot of people were having like problems. It's just that you need to remember to set the intercept true when you're using like the logistic regression in MLlib. And then it's really easy to just like apply the model on the parse test set and get your performance like metrics. So if any of you has some experience using this type of approach, I would be very interested to hear your thoughts, and because that's really like what we're starting to explore as a team at the moment. And yes, so just in time for you to run out of the fire exits. So this was in a nutshell how I went to like tackle this data challenge. Thank you very much for your time.
Annabelle, do you have something to share, like some of the code, or is this?
So I'll be sharing like the slides. I think they will be available on the website after the event.
Yeah, so we'll make all the slides freely available. Anyone who has or is able to open source their code, then obviously we will supply code as well. It just depends whether or not their code is associated to companies, because obviously they've got in terms of what's in-house and what's not, etc.
Yeah, I will need to check, but I doubt that I will be able to share like the.
Maybe open source snippets.
Yeah, or some snippets and.
I'm sorry.
Or just like some snippets. You know, if you have some questions about like a library or like.
Hi. Excellent talk. Thank you very much. I was just wondering, like a company like yours, I do understand the business model scope, but do you work with cities to help city planning, or is that something that's discussed internally?
So.
Or propriety and leaving it just within the company?
No, I mean we're like the company is very like open to use some other like data sources, and we participate to a hackathon organized by TfL. Looking at the data they capture using like sensors across the city. So I think TfL is also like looking to share this data. So I think the company has been quite proactive in terms of collaborations with.
Because one way of knowing if somebody's riding on a train or a car on a train is they just use their Oyster card,
yeah.
like that. Well, on the train.
Yeah. So yeah, for like London and like in cities where you have like this type of like tracking system, and when the data is available, that will be also very useful, especially when we start looking at bus versus cars. Yes, that's another interesting data set to merge.
Motorcycles. Motorcycle.
Yeah, more.
On the car side, do you find, I mean, anecdotally, that there are correlations between driving behaviour and claims?
Yes, so that's the initial purpose of like also having.
Is it the kind of thing that stands out loud and clear, or do you have to go digging?
So we are like refining because now that we are expanding, using like generalist client base, we see how that might like vary in different countries, and we refine the model to ensure that there's like a good correlation between the score and the claims.
Can I ask more a technical question? So was it the size of the data, or what was it that made you move to Spark, and how big a cluster are you using for Spark?
Yeah. So because we have two data engineers, they set up the size of the cluster for me, so I just tell them like the size of the data set I'd be looking at. I didn't use like the biggest cluster there, but still it's a pretty big data set because it's second by second point data for each journey. So it's I couldn't do it in R. Like R would locally R crashed like straight away. So I had to learn Spark on the job to be able to start the analysis.
For the smartphone case, have you thought about like passenger detection? Is that a problem? When somebody's not driving, but they're say in a cab or somebody else is driving.
Yes, so that's also one of the challenges we'll need to tackle. But so yeah, there are different ways to go about it, because you can like once you know the driving style of someone, then you can use that to identify if it's driving or not. But there's also some solutions more on the UX front-end side that can be used to prevent that from.
Could I ask Annabelle as well, what data are people happy to share, and what are they objecting? Have they either said or you've not tried to share?
So I mean, even if the end customers are like happy to share that data, so all these people have like voluntarily sign up to these like insurance schemes, and the insurers like disclose that they will be using that data to calculate the score and to personalize the insurance products they'll offer to them. So I would imagine that all the people that have signed up were like happy to share that data, and people who were not happy would not have taken this telematics options. I mean, of course, that's going to be like that's like an interesting debate, and we have to be very, very careful about that and make sure people are aware of what data they're sharing, especially when you start looking at e-health. So.
Two things that might be related, I'm not sure. The first one is Geoffrey French mentioned yesterday, a very interesting technique when you have the ground truth is expensive, is to do it first for 500 cases and then look at the badly classified or the exceptions, the one where you know it doesn't work. Have you thought about that? And second question, can you detect, I drove to the station and then I used the train, a single journey that has the two elements?
Yeah, so your first question was so using like taking the false positive and making sure that they can
into the false positive as a better feeding
yes,
the model
yes.
as a second step. Like first use a few examples, then do a second batch. I mean, Geoffrey's just sitting there, so he might be explaining the technique a lot better than I can because I learned about it yesterday. But
yeah, so so yeah, we'd be really interested to hear more about the technique.
Sorry.
Sorry. Yeah, so later we can discuss about it. But yes, so basically, when I first started, like, building like a model, I had a lot of car trips that were having many station points because they were like on roads running alongside like the rails. So I made sure that I had cases as part of my training set with like such trip to, so the model will like adjust for that. And your second question?
I was assuming that the cases that you have a hard time classifying are people that drove to the station first.
Oh yes. So about that. So usually what happens is that like the driving bit to the station is quite short, and then the train trip is longer. So we consider like the whole trip as being a train trip. However, in the future, we might want to break the trip into different parts. But that's something you can identify with like the speed standard deviations, because if you plot the speed, you have the first bit when the person is driving with really like short cycles and like a short range, and then when you have the train, you have like again like those kind of like longer like cycles, because like the train can like, unless a car is on the highway, a train is able like to go to higher speeds.
Could I ask you about data cleaning?
Yeah.
I mean, I know that I have Strava on my phone, and sometimes it jumps all over the place. It's obviously not ideal, perhaps from classifying something, but also just for seeing whether someone's driving properly or not. I mean, what sort of approach do you find useful for?
So, because I was using, so for the scoring process, we of course clean the data when we process it and like snap it to the road. So we apply, another engineering team is applying different type of filter, I think like a Kalman filter, so you don't have this bumpiness. So I was using some process data that was already clean thanks to the processing, and to get like the variables such as the count of stations, that was not too much of a problem. So yeah, I could benefit from the work of the the engineers.
I've got a question about the the sort of OBD devices versus the smartphone apps. So apart from, put aside the OBD can give you like vehicle analytics, is there any sort of, do we know which one is, say, better, or the sort of the use cases around those two? Because they kind of, the smartphone can do a lot more processing, but I think, from the jury might still be out, so I just wondered if you
Yeah. So I mean, my understanding is that people are increasingly looking at mobile applications solutions because it's cheaper and faster and like easier to like implement. And in terms of the quality, so yes, like the newer device gives you like some better data than the older like device as a general rule. So it really kind of like depends on what the insurer wants to develop as a product. If it wants to have some like really the most precise data and the company doesn't care about the cost, then I guess they might go with an onboard professionally like installed device. If they want something that it's easier to distribute and to reach like a bigger like market share, then I guess like the mobile application. It's often like a business question.
So if there is no more question, then thank Annabelle again, and then we have coffee breaks.